These notes are for Module K, Unit 2, Lesson 1. The topic is representing data. There are 4 learning targets in this lesson. The first one is I can create tables, graphs, and models to display scientific data. That means you need to know to include a title and label the variables on the X and Y axis. The second learning target says I can interpret tables, graphs, and models to analyze scientific data. So to meet that learning target, you need to be able to look at a graph and explain the information it contains, as well as identifying the parts of the graph. The third learning target is I know the difference between linear and nonlinear graphs. And the last learning target is I know the difference between inverse and direct relationships. As you can see, even though you may have had some experience with graphing, say in a math class, we'll be using some different vocabulary in this lesson that you probably haven't learned or been exposed to before. There are 3 vocab words in this lesson. An independent variable is the variable the researcher manipulates or controls in the experiment. This is the variable that drives the experiment. The second vocab word is dependent variable. This is the variable the researcher measures. And the third vocab word is model. A model is a pattern, plan, representation, or description designed to show the structure or workings of an object, system, or concept. This word is included in this lesson because the graphs we will be making and the data tables we'll be using are considered mathematical models. In this lesson, I do like the pages that come in the workbook, and so we use the student edition starting on page 66. You can find that in Think Central if you click on My Library and then Student Edition. We looked at the data here and determined that on the left side of the data table, we find the independent variable, high temperature. And on the right side of the data table, we find the dependent variable, number of cold drinks sold. So even though I can't control the temperature, that is what drives the number of drinks sold. As the temperature increases, people purchase more drinks. So high temperature is the independent variable. Then on the next page, we looked at different types of graphs and a strategy for completing a scatter plot. Notice that on this graph, the line of best fit does not connect the dots. It goes through the center of them. And we learned on this page that on a data table, we find the independent variable on the left side, and then we transfer that to the x-axis of a graph. On a data table, we find the dependent variable on the right side of the table, and then we transfer that to the y-axis of the graph here. The next page talks about other types of graphs. You'll find a good explanation in the Bozeman Science video on Schoology, the Intro to Graphing video. We took the information from the Visualize It problem and created a data table to show Dwayne's mile training times. We included a title, column headings. We put the label for minutes here so that we didn't have to write it on each line. And then we transferred that information to the graph on the next page and made our own scatter plot. Notice that time in weeks goes on the x-axis because that's the independent variable. Time in minutes goes on the y-axis, and it's a scatter plot, so we drew a line of best fit. Then on the last 2 pages of the lesson, we read about the difference between linear relationships, when the graph looks like a straight line that I could trace with a ruler, and nonlinear relationships, where the graph is a curved line. That's one of the learning targets, as well as direct relationships, when a graph like this goes up and to the right, both variables are increasing together, and inverse relationships like this one, where the graph goes down and to the right. As one variable increases, here it's pressure, the other decreases, volume is decreasing. So the graph of Susie's Surf Shop sales is both direct, it's moving up and to the right, and nonlinear because it's curved. In the notes, we included a sample data table and a sample graph. So I had students make their graph look like mine. We just labeled the parts. So the title, x-axis, which is the independent variable, that's often time. Y-axis contains the dependent variable, that's the result of the experiment. And then the line. And on the data table, we labeled the independent variable on the left and the dependent variable on the right. The data table in your notes is wide, instead of tall, like mine is. Then you'll need to add this to your notes. A line graph is a graph that shows information that changes over time. This graph shows changes in temperature for the city of Plymouth throughout the calendar year. A scatter plot shows the correlation or relationship between two variables. We don't connect the dots. A bar graph, and this picture is actually a histogram. The bars shouldn't touch. A bar graph shows information in categories. A histogram has bars that touch. This shows the distribution of data, so now the bars do touch. And then a circle graph shows information about an entire group. And in the Bozeman Science video, Mr. Bozeman said, we take the information from a data table and put it in a graph because when we can see it, then we can make sense of the data and we can understand it. And you can see that's true with all of these graphs. Lastly, the slope of the line tells the rate of change. So the faster your graph is going up, the faster that thing is changing. A line like this one that slopes up shows an increase, and that's a direct relationship. A line that slopes down, like this one, shows a decrease. That's an inverse relationship. A flat line shows no change. And then here I added some illustrations for a linear graph, a straight line, and a nonlinear graph, any graph with a curve. Those are the notes for Unit 2, Lesson 1, Graphing.